All right, today we're going to be using intercept form. You may hear me refer to this as factored form because this is going to look like factored form. It's the same thing. So if I say intercept form or factored form, it's going to be basically the same thing, but that's what we're going to be looking at today. All right, here's a list of your standards that will go along with this lesson today. Please review those. To be successful today, you need to be able to graph a quadratic function of the form f of x equals a times x minus p and x minus q. Again, this is intercept form. I call it factored form. If you remember a few lessons ago, we talked about factoring and it looked very similar to this. All right, so find the zeros of functions using intercept form. Use characteristics to graph and write quadratic functions and cubic functions. I will say they call it intercept form because your factors will create your x-intercepts. So I guess that's why they call it intercept form. All right, vocabulary, intercept form. In intercept form, a polynomial that defines a function is in factored form and the x-intercepts of the graph can be easily determined. Intercept form of a quadratic function is f of x equals a times x minus p is one factor and x minus q is your other factor. A is not equal to 0 or you do not have a quadratic equation. All right, key ideas. The x-intercepts are p and q, so you can see here p and q. If you have the factors, you can quickly and easily find the intercepts. The axis of symmetry is halfway between p and q. So basically you're going to find the average of your p and q. P plus Q divided by 2, that's finding the average so that you can find the axis of symmetry or the vertex. If the graph opens up when A is positive and the graph opens down when A is negative, that's the same as what we learned before. And the x-coordinates of the vertex is P plus Q divided by 2, or the average. Add them up, divide by 2, that's how you find the average. All right, key ideas, factors and zeros for any factor. X minus n of a polynomial n. N is a zero of the function defined by the polynomial. Remember, 0 is another name for solution. So you're going to be able to take the factor, find the 0 or the solution of the equation very quickly. All right, example 1, graph and find the domain and range. All right, so we're given f of x equals negative x minus or x plus 1 and x minus 5. So because of that negative, that would be our a value. We know that it's upside down parabola, and we can find our p and q quickly by definition by just looking at the factors. So we know that we're going to have one intercept at -1. So we can put a point at -1. We can have another point at 5. So we're going to have another point here, and then we can find the average of that to find the vertex. All right, so -1 came from taking x plus 1, setting it equal to 0 and solving. So x equals -1, so I'm going to have -1, and then x minus 5 equals 0. I added 5 to get my other x-intercept here at 5. And then again, to find the average, you take the numbers, add them up, and divide by 2. So -1 plus 5 is 4. 4 over 2 is 2. So I know that's the x value. All I have to do is plug 2 in to find y. So y equals negative times 2 plus 1 and 2 minus 5. So I'm going to have -3 times 2 minus 5 is -3. So that would be 9. All right, so I have a vertex at 2, 9, where the axis of symmetry is 2. All right, that gives me my third point. So if I come over 1, 2, and go up 9, that gives me 3 points here. Let's see, I can go ahead and graph this. Again, you know it's upside down because it is negative. And so intercept form is also just another way to write quadratic equations, but it's also quick and easy to graph if you can graph the two intercepts, find the average of P and Q to find the axis of symmetry, graph the vertex. Once you have 3 points, you can sketch that curve very quickly. All right, the last thing it says is to find the domain and range. All right, domain again is your x values. It's a curve where it has arrows going continuously left to right. So we're going to have still got my arrows going. Hold on a second. All right, we'll try that again. So my domain is going to be all reals, so negative infinity to infinity. Again, it's got arrows going left and right forever. And my range is going to be everything less than my vertex, which is 9. So y less than or equal to 9. All right, I want you to take a couple minutes. I want you to see if you can do B part. Find the x-intercepts from the factors, and then find the vertex, graph your 3 points, and sketch the curve. Then determine what is the domain and range as well. Once you have time to do that, come back to see how you did. All right, for B part, hopefully you took a minute to do this on your own. You could see that x plus 2 is one factor, so one of your zeros is negative 2. Remember, all you have to do is set the factor equal to 0 and solve. To solve for x, you would subtract 2, which gives you x equals negative 2. Same thing with the next one, x minus 3 equals 0. Add 3 to both sides, so you'd get x equals positive 3. All right, once you find your two intercepts, that's your two x-intercepts, or zeros, and then you can find the vertex and the axis of symmetry by finding the average of P and Q. So P and Q, remember, are your two zeros. So negative 2 plus 3 divided by 2, so it's going to give me 1/2. And then I take 1/2 and plug it back in for x to find f of x, which is my y value. So 1/2 plus 2 is 2.5. 1/2 minus 3 is negative 2.5. And then if you multiply 2.5 times negative 2.5, you get negative 6 1/4. All right, that would be negative 6.25, which is the same as negative 6 1/4. Since I used fractions up here, I wanted to use fractions all the way through. So I got 1/2 and negative 6 1/4. So if you come over, 1/2 is going to be halfway between 0 and 1. Negative 6 1/4, I come just 1/4 of the way down past negative 6. Once I have 3 points, I can sketch the curve. Domain again would be all real numbers. Your range would be all y values greater than or equal to negative 6 1/4. All right, example 2, graph, find the domain and range. Okay, so the same question. Looks a little different. It's not in factored form, but hopefully when you look at this, you see that 2 and 8 are both multiples of 2, and you can quickly put this in factored form. So I'm going to say 2 times x squared minus 4. Remember that x squared minus 4 is a perfect square minus a perfect square, so this is called a difference of squares. So I'm going to have 2 times x plus 2 and x minus 2. All right, once I do that, I know what my factors are, then I can find my zeros. All right, my zeros are my solutions, my x-intercepts. So if I have x plus 2, set that equal to 0, I get negative 2. And then x minus 2 equals 0, add 2, I'm going to get plus 2. All right, just like before, I'm going to take my P and Q, which is negative 2 and 2, and average those. So negative 2 plus 2 is 0. 0 over anything is 0. So I know I've got an x of 0. What would my y be? So my y would be 2 times 0 squared minus 8. Again, I'm just plugging this into the original equation. 0 squared is 0. And then, oh, I put my parentheses in the wrong place. I wondered what I was doing here. Hold on one second. All right, negative 2 times x squared and then minus 8. All right, so 0 squared is 0. 0 times anything is 0. So this is just negative 8. So I've got another point at 0, negative 8. So 0, negative 8, and then I can graph it from there. All right, it says find the domain and range. Just like before, my domain is going to be all real numbers. All right, and my range is going to be everything above. See, it goes up. So it's going to be everything greater than or equal to negative 8. All right, B part, you have to factor it as well, and then graph, find the domain and range. I want you to pause the video, see if you can do that on your own, and then we'll check it together. All right, this one's going to look a little bit funny. So we have factored 4x squared minus 36. Factor out the 4. I've got x squared minus 9. Again, that's a difference of squares. So I've got 4 times x plus 3 times x minus 3. That gives me my two zeros, or x-intercepts, at negative 3 and positive 3. And then I can find the average of those two to find the vertex of the axis of symmetry. So negative 3 plus 3 divided by 2 is 0. Plug in 0 to find the y value, and I get negative 36. That should make sense because there's no middle term, so that means negative 36 is my y-intercept, and the y-intercept in this case would be the vertex as well. So you can see the scale. If I went by ones, it only goes down to 10. You've got to go way down to get to negative 36. So the graph looks a little bit skewed. I should have used a different scale, but it was already here, so I left it. Domain, all real numbers again. Range is everything greater than or equal to negative 36. If you have any questions with that, please let me know. All right, example 3, finding zeros of a function. All right, so this is already in intercept form, which I call factored form sometimes as well. But because you already have this factored, you can use the zero product property to quickly set it equal to 0, which is already what I've been doing in order to graph the zeros or the intercepts. So I don't know why they put this as example 3 instead of example 1, but let's show what we're doing here. So x equals 1, subtract 2, x equals negative 2. So our zeros are 1 and negative 2. So that would be the solutions for f of x. All right, for this one, I've got x minus 6 equals 0, x minus 7 equals 0. So I'm going to add 6 to both sides. X equals 6, add 7, x equals 7. So you can see that you can go from the factor, x minus 1 is the factor, and x equals positive 1 is the 0 for that factor. X plus 2 is the factor, x equals negative 2 is the 0 for that factor. So it says, remember, functions have zeros and graphs have x-intercepts.